Let's start. Okay, so in this particular session, so we'll learn about how to determine the order of a time series. Okay, the order of time series model. Okay, and then we'll also learn about the difference method. Okay, how to make a non-stationary to stationary. Okay, so these are the two important things that we'll learn in this case. Okay, all right. So what have we learned so far? So we learned in the last video, we learned about how is time series model different from the structural models, right? Regression models, right? We learned about what are AR model, what are MA model, what are ARMA model. Okay, so AR is just YT equal to YT minus 1 plus this thing, sorry, and then MA is just, you know, YT is a linear combination of the error terms, right? ET minus 1 plus ET, where ARMA is a combination of AR plus MA, right? ARMA is a combination of AR plus MA, right? That's what we have learned so far. Yes, and these are stationary models. These are stationary model. That means for these models to be to be working good, or to be able to forecast it properly, the YT has to be stationary. YT has to be stationary, right? Yeah, stationary. Okay, just to remind you what stationary is, stationarity. Okay, just look at these two graphs. Okay, this one, or maybe there is, okay, there is constant mean, or if there is non-constant mean or non-constant variance, then it's a non-stationary, right? This is non-stationary. This is also non-stationary because this mean is not constant. Here also the variance is not constant, but here the variance is constant. Also the mean is also constant, right? So this is a typical stationary case, right? So AR, MA, ARMA are all stationary models. That means when you see a trend like this or a non-constant variance like this, these models AR, MA, ARMA cannot be used in this case. Cannot be used in this case for forecasting purpose. Yes. So we convert this non-stationary to stationary. Okay, and that's how we also do forecasting. So these are the few things that we'll learn in this particular session. Okay, so the first one is, let's start with how to find out the order of the time series model. Okay, order of the model. That means how many lags to be included, how many error terms to be included in the ARMA and ARMA model. Okay, so there are two functions which are used. One is ACF, the other one is PACF. Okay, ACF is known as auto correlation function, and this is called partial autocorrelation function. Okay, now using these two, ACF and PACF, we will be able to know how many what should be the order of the model, because you might be confused whether AR model should be used or MA model should be used, right? You must be confused whether AR1 should be used or AR2 should be used, right? AR1 must have, it means there are only one lag, and AR2 means there are two lags, right, of the same variable. That means it has got YT minus 1 and yt minus 2 in the right hand side of the variable, right? Right. Similarly, in the MA, you will be confused whether it's MA1 or it's MA2 or MA3 or so on, right? So what you do is that you plot the ACF and PACF, okay? ACF and PACF are no some sort of a correlation function. So ACF is nothing but the autocorrelation function. That means the correlation of YT with YT minus Y. Yeah, is yeah. Okay. So current value with the past value, sorry, not the future value. Current correlation of current value to the future values. Partial autocorrelation function is slightly different. It simply takes away the effect of intermediate values. For example, this is like correlation of some sort of a correlation. Okay, yt t minus s. Okay, that means t is the current time period and t minus s time period. That means if t is, let's say, y of 10 and then s is let's say 5, then y is 10 minus 5, which is y of 5. So we are taking correlation of y5 and y10 and y5. These are historical values. No, this is the historical values. 10 period, 10 period and yeah, 10. So yeah, right. So what we do is that in partial autocorrelation function, we simply take out some of these effect. Okay, we take out y9, we take out y effect of y9, y8, y7 and y6. Okay, so we take out some of the intermediate values and find out the correlation. Okay. So let's say it's a stock price. Okay, so in partial autocorrelation function, it also measures the correlation. Okay, but the problem is that it takes out the effect of some of the intermediate series data series. Okay, so it takes out the intermediate effect. That means the effect of y9, y8, y7, y6 is not taken out, and s could be any number. Okay, so it may not be just 5, it could be some sort of a significant number. Okay, so don't worry about the theory of ACF and PACF. Okay, just these are some correlation functions, two kinds of correlation functions used to find out the order of the time series model, the ARMA and ARMA. Okay, and I'll talk about what is the significance of this. Okay, if you want to learn more about the derivation of this function, you can watch the video on the YouTube that I have shared on my channel. You can watch the video time series theory, and that there I have explained it properly. I have done the derivation also. Okay, but here we'll just see what the significance of. So the ACF and PACF, what you are trying to find out is whether correlation is significant to the SH lag, right? So what happens is that, let's say you plot the correlation. Okay, you plot the first lag. This is lag 1. Okay, lag 1. You understand what is lag, right? This is lag 2. This is lag 3. So naturally, when time series is there, when you go down the lag, when you go backward, right, the effect of the lag will be less, right? Lag 1 to lag 3. For example, this is, okay, let me give an example. This is stock price, ST. Okay, this is today stock price. Okay, so and then this is yesterday stock price, this day before yesterday stock price. So this will be more correlated, or this will be more correlated for this one and this one, right? Okay, then when you go down, the correlation should go down. No, I'm saying when you go down the series, when you no, I'm so what I'm asking is that if you think logically, if you go down the series, the more lags you have, the more less correlation it will have, right? With the current series. That's logical, right? So we will see that the correlation value will come down naturally, right? So we want to know till what correlation we have a significant impact. Okay. And only those many lags will be taken in the time series model. Right. Yes. We are going to see the curve shape and we are going to see to what extent this is significant. So let's say this is a significant line. Okay. And we determine that till this point the correlation is above this line, significant line. And then we'll take the first three lags, something like that. Okay. Right. Yeah. Okay, so um, let's look at this particular thing. Okay, so we have got the ACF and PACF, right? The ACF for a AR model spikes decay towards zero. Okay, so it's a slow decay. Okay, and the PACF cut off at zero. Okay, in the case of MA model, spike cut off to zero for ACF, spike the PACF spikes decay towards zero. Okay, I'll explain. And for the ARMA PQ, it spikes decay to zero and spikes decay towards zero. Let me see. If I have the curves. Let me see. Okay, I don't have the curve. Let me. Okay. So let's plot the ACF. Okay, and we are plotting it for AR model. Okay. So for AR model, this is let's say lag 1. Okay, this is ACF autocorrelation function, autocorrelation value. Okay, lag 1 and then lag 2, lag 3, lag 4 and so on. When we see the ACF function gradually coming down, we know that this is the AR. This cannot be MA. This cannot be MA. This is AR. Right? So when you plot the ACF function of a time series and the ACF function behaves like this, then you be sure that this is a AR model. Okay. ACF autocorrelation function. Okay. Now how do we know the lags of autocorrelation function? For that you have to find out the PACF. Okay. In fact, from ACF itself you can find out the lags. I mean, just look at till what extent you have this, you know, significant value. If it is like the first two lags are significant, then it's a AR2 model. If the first lag is significant, second one is not, then it's a AR1 model. So that's how you determine whether it's AR1 or AR2. Right. The PACF will be, for example, if it is AR1 model, then the PACF will have only one curve at lag 1, and then all this will be 0. Rest of the lags will be 0. Here it's like slow decay, but here it is like lag 1 and then 0. Okay, if there are two significant lags, then there will be 2 lags here and then exactly 0 after that. But here there is slow decay. ACF is slow decay. If this pattern is found in two time series, then we call this is a AR model. Okay, this series follows AR model. You got the point, right? Mm-hmm. Yeah. Yeah. Yes. Right. And the PS, the PSAF should be exact, matlab sudden drop. Yeah. On the other hand, the MA is exactly opposite. In MA, the ACF will have sudden drop. Okay, the ACF will have sudden drop. The PACF will be gradual. and so this is exactly opposite of figure. Okay. And now see for how many lags the ACF is significant. Okay, if there are 2 lags for which is significant, it's above the significant line, then it's a MA2. If there is only 1 lag, then it's a MA1. Okay, that's how we degree. ARMA is again, so this will be directly given, there is some 95% confidence level is there, right? So then significant hypothesis testing will be done upon it, and then you will come to know which one is significant, which one is not. That is a statistical test for stationarity, not for order of the model. Order of the model is only found out from ACF PACF. Okay. The ARMA is a combination of AR and MA, right? So in ARMA, both ACF and PACF will have a decay. We have a gradual decay, right? Both ACF and PACF will have gradual decay. Okay, so that is one thing to be understood properly. Okay, so these are the rules through which you can find out whether it's a MA1, AR model, ARMA model, what is the order of the model, and so on. Okay. All right. So when we do this in R, we'll see how do we fit the order. Okay. It's very easy. It's not that complicated. Okay. You just try out, because this calculation is actually done by R itself. You just have to interpret. You should know how to interpret this ACF and PACF graphs. Okay. All right. So next one is ARIMA, right? Right. So we learned in the first part of the session is that whenever there is a non-stationary series, then we have a problem, right? MA, AR, ARMA are not going to work, right? For non-stationary. We can make non-stationary into stationary series. Okay, we can make it stationary. Okay, so if a curve is like this, something like this, when you take the difference of that, okay, this is yt, let's say this is yt, you take the first difference, that means delta of yt is equal to yt minus 1. Let's say this is the first difference. Okay, so when you take the first difference of that, you will get a more stationary series. Okay, it may not be 100% stationary, but it will be more stationary. This could be something like this, or this is more stationary than this. You may have to take the second difference, okay, and then this will be more stationary. Okay, second difference will be something like this. Y, okay, second difference is, let's say, okay, this is, okay, just excuse me for the notation could differ. Okay, okay, all right, you got the point, right? So this is the second difference. So when you take the first difference, second difference, you might have to go for third difference also. Okay, so when you do this Dickey-Fuller test, you will be able to find out whether a series is stationary or non-stationary. Then if it is stationary, you go ahead with your AR, MA, ARMA model. Okay, if it is non-stationary, then you do the difference and then check it if it is stationary again or no. If it is not, then do another difference and then again check the stationarity using Dickey-Fuller. Okay, then when it is stationary, and then you apply your ARMA model on it and then find out the forecasting. Okay, that's what so in Right. Yeah, there there are chances, but in that cases, see, most probably it is not going to be. It will be somewhat stationary. Okay, but there are also chances. There is a slight chance. Yeah, there will be problem with accuracy. So there could be such problems also. But most of the times, if it's a non-stationary, you can make it stationary. Not a problem. Now you understood what ARMA is, right? All right. All right. So as I was saying, ARIMA is nothing but autoregressive integrated movie angle, right? So this integrated part is nothing but your difference. The first difference, second difference that you are doing. Okay. Right. So in ARMA you have P and Q, right? So P is like the A atoms, Q is M atoms, right? Here it's okay. So this is nothing but P A atoms, D number of differences, whether you have done first difference, second difference, third difference, or whatever. K is the movie, the M atoms. Okay. So D is the number of differences, P is the atoms, Q is the moving average terms. Okay. So when you combine these three, you get what is known as the ARIMA PQT. Yes. The difference is nothing but the number of times you are differentiating the time series before making a test. Yes. Right. Right. So you can also say that okay, the ARIMA, let's say the ARIMA 100 is nothing but an AR model, right? Because it has only one atom, right? Similarly, an ARIMA 001 is an MA model, right? Yeah. This is like ARMA, right? So ARIMA is like the one general class of models, right? All right. So yes. So if what so the yes. So if you have a time series data, the first thing that you need to do in a time series model is do your extra exploratory data analysis. Okay, find out step one, right? And then you do some sort of a statistical test. Okay, you do Dickey-Fuller test, Dickey-Fuller test to know stationarity, right? Stationarity test, right? Stationarity test. Yes, stationarity. No, stationarity, right? If it is yes, then go ahead and try AR, MA, SCA, ARMA based on ACF and PACF, right? If it is non-stationary, then do differential, okay? And then use AR, MA or ARMA, right? And how do you choose models? You choose models based on the AIC, archaic information criteria, the SBIC, okay? Lesser is the AIC, better is the model. You can also use the forecast error. Okay, if you are taking a data set, building a model, the model which is providing you least forecast error is the best model, right? That easiest. No, that's there in the video I have shared with you, so you don't have to note it down from here. Okay, don't worry. I'll yeah. So this is what the basics theory of ARIMA model. I'm sure you have like a fair bit of understanding about it. So in the next particular session, we'll take a data set and do it. We'll build the model, okay, in R, so that you will get a better understanding of it, how you build it and how you test the model. Okay, all right.